Good day, students. Welcome to a mixed review on sum and difference, double angle and half angle identities. So let's go ahead and take a look at the first question. For number one, we're here to find the exact value of sine x plus y, cosine x plus y, um, if sine x equals 2 over 7 and cosine y equals 4 over 5 with x and y in quadrant 1. All right. Okay, so let's go ahead and start with the first one we need to find, which is sine x plus y. So A, we want to look for sine x plus y. So using some identities for sine x plus y is basically sine x cosine y plus cosine x sine y. Okay. If we look at this problem, we notice we have sine x, we have sine x, and we also have cosine y, but we need cosine x and cosine y. All right. So to find those missing pieces, let's partition our workspace. We're gonna find the missing pieces on the right side over here. Okay, wrong line. Different line. So let's divvy it up. All right, so we want to find cosine x and sine y. All right, so first thing we want to do, let's find, what should we find first? Let's find cosine x first, okay? Find cosine x. So to find cosine x, we're going to use the identity cosine x equals plus or minus the square root of 1 minus sine square x, okay? All right, we know that sine x is 2 over 7, so we're going to plug that in here. So we'll have, this is going to become plus or minus the square root of 1 minus 2 over 7 square. All right, so we'll square it, we'll have this plus or minus 1 over 1 minus 4 over 49. Okay, now we'll find the LCD and combine them. So we're going to have plus or minus the square root of 49 over 49, which is the same thing as 1 over 1, minus 4 over 49. When you subtract the numerators, you end up with plus or minus root 45. When I root the bottom, I'll end up with 7. Okay? Can I simplify root 45? Let's see. If you take root 45 and you try and break it down, take out a 5, you're left with a 9. 9 can be broken down into 3 and 3. These two repeat, so they can be factored out as a square root, which is 3. So our answer is going to be 3 root 5. Okay? So we have cosine x becomes plus or minus 3 root 5 over 7. So the question now is it positive or negative? Well, since we're in quadrant 1, what do we know about quadrant 1? Let's go ahead and sketch out quadrant 1. So there you have quadrant 1, the coordinate system. Now, this is quadrant 1 right here, and we know all students take calculus. So, since this is quadrant 1, A means all 6 trig ratios are positive, trig functions are positive, hence, cosine x is going to be positive in this quadrant. So we have cosine x equals 3 root 5 over 7. Okay, so this is one of the answers we need. Oval around it. It's one of the answers we need. I'm not boxing it because it's not the final answer. All right, now let's go ahead and look for, we now need to find, what do we need to find? Sine y. Okay, so let's go ahead and find sine y. I'm going to retain my partition so I don't get confused. All these are just like the side work, okay? It's not like the main domain. All right, so let's find sine y. So how do we find sine y? To find sine y, we're going to use the identity sine y equals, well, since we're in the first quadrant, we know it's going to be positive, so we don't have to put plus or minus, right? Equals the square root of 1 minus cosine squared y. All right, this is one of the identities that's a variation of your Pythagorean identity, okay? So I have square root of, what is cosine y? We need to go back to the question. Cosine y is 4 over 5. So I have 1 minus 4 over 5 square. Okay? All right, so that becomes the square root of 1 over 1 minus 16 over 25. When we make the LCDs the same, we'll have the square root of 25 over 25 minus 16 over 25. We'll subtract the numerator, we'll have the square root of 9 over 25. When you root the top and the bottom, you end up with sine y being 3 over 5. Okay, so there goes your second sub-result. Let's put a circle around it. Okay, now we have everything we need. Let's go ahead and list them. We have sine, let me write it down here so we don't get confused. So sine x is 2 over 7. Cosine x is 3 root 5 over 5, 3 root 5 over 7. Sine y is 3 over 5. And then cosine y is 4 over 5 from the original question, okay? So we're now ready to plug everything into the problem to solve it. So we're going to have sine x plus y equals sine x, which is 2 over 7, times cosine y, which is 4 over 5, plus cosine x, which is 3 root 5 over 7, times sine y, which is 3 over 5. All right? So multiply the fractions across, numerator with numerator, denominator with denominator. We'll end up with 8 over 35 plus, and then here you multiply the 3 and the 3, 9 root 5 over 35. Expressing this as a combined fraction, our answer for sine x plus y will be 8 plus 9 root 5 over 35. Okay, so there goes your final result for sine x plus y. All right, let's go ahead and look for the second part, part B, which is cosine x plus y. The cool thing about this part is we have all the ingredients we need, okay? So for cosine x plus y, using the sum identities for cosine, we'll have cosine x, cosine y, minus sine x, sine y. All right? So I'll plug in those values that we just determined up here. We're going to have cosine x is 3 root 5 over 7. Cosine y is 4 over 5. Minus sine x is 2 over 7. Sine y is 3 over 5. Okay? Now we're going to multiply it out. Numerator, numerator, denominator, denominator, we have 12 root 5 over 35 minus 6 over 35. Okay, if I express it as a combined fraction, I'll have 12 root 5 minus 6 over 35. And there goes your final answer for cosine x plus y. Okay? All right. So that's that. All right, let's move on to question number 2. So for question 2, we are to, number 2, find the exact value. Find the exact value of sine 2 theta, cosine 2 theta, and tan 2 theta, where cosecant theta is equal to negative 7 over 4, and we have pi is less than theta, and theta is less than 3 pi over 2. All right, let's go ahead and do this. First thing we're going to do for the A part, we're going to look for sine 2 theta, okay? Because that's what we're asked to find first. So the double angle identity for sine is 2 sine theta cosine theta. Okay? If you notice, we're given cosecant, so we need to actually find what cosine and sine are. So I'm going to partition my workspace. I'm going to do some work here to find out what sine and cosine are so I can determine what sine 2 theta is. Okay? So first thing we want to do, let's see. We know that cosecant theta is equal to negative 7 over 4. What does this tell me? Cosecant is a reciprocal of sine, right? So this implies that sine theta is automatically the reciprocal of negative 7 over 4, which is negative 4 over 7. Okay? Now we have sine. Now we need to find cosine, right? So to find cosine, we're going to use the identity cosine theta equals plus or minus the square root of 1 minus sine squared theta. Okay? So let's see. Sine theta is negative 4 over 7, so we're going to plug it in here. So we have cosine theta equals plus or minus the square root of 1 minus negative 4 over 7 squared. Okay? So let's simplify that. We'll have plus or minus the square root of 1 over 1 minus 16 over 49. Because when we square the minus, it goes away, so this minus stays the same, okay? So we have plus or minus the square root of 49 over 49, which is the same thing as 1 over 1 if you multiply this by 49 top and bottom, minus 16 over 49. When we subtract the numerators, we will have plus or minus the square root of 33 over 49. Separating them, we'll have plus or minus the square root of 33 over 7. 33 breaks down into 3 times 11, hence it cannot be reduced because no factor repeats. The question we have to ask ourselves now is this going to be positive or negative? That's the question. Okay? So we'll make our coordinate system. What quadrant are we considering in this problem? Between pi and 3 pi over 2. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so what quadrant are we looking at between pi and 3 pi over 2? This is quadrant 3 right here. We know that all students take calculus. So in this case, t is a trig function here. So we know tan and cotangent are positive. Everything else is negative. We do not have a match. So that tells me that cosine theta is actually negative root 33 over 7. Okay? Because cosine is neither tan nor cotangent. We don't have a match here. Okay, so we have everything that we need. So let's go ahead and put them here. We know that sine theta is negative 4 over 7. It's a consequence of reciprocation here. And then cosine theta, using the version of the Pythagorean identity, we determined that it was negative root 33 over 7. All right, so we're going to plug these two in here. So we have sine 2 theta equals 2. Sine theta is negative 4 over 7. And then cosine theta is negative root 33 over 7. So our final answer, we can write this over 1, okay? So multiply the numerators across and the denominators across. So we'll have negative 8 root 33 over 7 times 7, 49. Okay, so that's sine 2 theta. All right, we have one answer down, two to go. And let's go ahead and look for cosine 2 theta. Okay, so for cosine 2 theta, let's call that B. For cosine 2 theta, we're going to use I like to use the identity that's least processed. Well, I know that sine is the closest to the problem I have, negative 4 over 7. So how about we use the formula cosine 2 theta equals 1 minus 2 sine squared theta. Okay, this is the least risky answer to use. Component to use because it's the least processed one. Okay, you can use other formulas, but I like to use this one. All right, so we're going to have 1 minus 2 sine theta is negative 4 over 7 squared. Okay, so that becomes 1 minus 2 times, when you square the numerator and the denominator, you have 16 over 49. And then multiplying across, you can write this 2 over 1, okay? So you multiply across here. So you have 1 minus 32 over 49 So right, it says 1 over 1. We need to find the LCD, multiply this by 49 top and bottom. So we have 49 over 49 minus 32 over 49. Okay? Subtract the numerator, we'll end up with 17 over 49 as a result of cosine 2 theta. So cosine 2 theta is 17 over 49. Okay? All right. Now let's go ahead and find the third or double angle trig function, which is tan. Let's extend this so we don't get confused. This was our sidewalk right here. Partition it away. Okay, so now we need to find tan 2 theta. So to find tan 2 theta, I'm going to use the quotient identities, which basically is sine 2 theta over cosine 2 theta. Okay? So I'm going to be using these answers. Note, these are not the ones I'm using. This is cosine theta, and this is sine theta. Let's scroll up a little bit. This is sine theta, and this is cosine theta. It just has one theta here and one theta here. This formula calls for the use of 2 theta, so I'm going to be using this answer right here and this answer right here. Let's write sine 2 theta. So it's my final answers that I'm actually going to be using. So these are the ones I'm using. I'm done with this, okay? So forget about that. So I'm going to be using these two, all right? So since they're both fractions, I'm going to write them horizontally, okay? So we're going to have negative 8 root 33 over 49 divided by, this is sine, right? Cosine is going to be divided by 17 over 49. All right, so what do we do next? We multiply this by the reciprocal of that, right? Drop, change, flip. So you drop the first one, negative 8 root 33 over 49. Change this to times, and then you flip this 49 over 17. Okay? And then if you notice, the 49s divide out. 1, 1. And we multiply across, you get the value of tan, which is negative 8 root 33 over 17. Okay, so there goes the value of tan 2 theta. So there you have it. Okay, so let's go ahead and put all our answers in an organized list. So we have sine 2 theta equals negative 8 root 33 over 49. Cosine 2 theta equals 17 over 49. And lastly, tan 2 theta equals negative 8 root 33 over 17. Okay, so there goes our three results. Okay, there you have it. Now let's proceed to problem number 3. All right, so for problem 3, we have, we're gonna find the exact value of sine theta over 2, cosine theta over 2, and tan theta over 2, have angles here, when theta is equal to 3 over 4, I'm sorry, when cotangent theta. When cot theta equals 3 over 4, and 180 degrees is less than theta, and theta is less than 270 degrees, okay? All right, so let's go ahead and do this. So to do this, what we're going to do first is the A part, okay? The A part, we are looking for sine theta over 2. So we're going to use a half angle identity because you notice the angles have been divided by 2 here. The half angle identity for sine is plus or minus the square root of 1 minus cosine theta over 2. Okay? So in this case, we do not know what cosine is, so we need to determine it from cotangent. So we need to do some side work to find our missing ingredient. So let's partition our workspace. I'll look for cosine first, okay? We're going to need sine to find tan theta over 2, so let's find both of them. We need to find sine and cosine, okay? So let's see what we have. We know that cotangent theta equals 3 over 4. Well, what does this mean? Well, it follows that tan theta equals the reciprocal of this, 4 over 3. Okay? Now we're going to use SOHCAHTOA to help us construct the right triangle that will enable us to determine what sine and cosine are. Okay, so the numerator, this numerator right here, is your opposite, and the denominator right here is your adjacent. Well, how do I know? You just write SOHCAHTOA, right? So SOHCAHTOA. So we can see that tan is opposite of adjacent, right? So from the same triangle, we're going to find sine and cosine. So let's go ahead and draw the right triangle, considering this quadrantal restriction here. So I'm going to exaggerate the quadrant that's between 180 and 270. That should be quadrant 3. I'm going to make that one the biggest one. So there goes my y-axis and my x-axis. We have, let's put in the value of the angles. So this is, we have 0 degrees, 0 pi over 2, pi, actually I'm supposed to go with degrees, right? Yeah, why am I doing this? Anyway, let's use degrees. So 0 pi over 2, same thing as 90 degrees. So 0, 90 degrees, 180, and this is 270. So we're going to be in this quadrant right here, okay? So we're going to draw the triangle in standard position. So it's going to be sitting on the x-axis, and theta is going to be our reference angle, which is an angle to the closest x-axis. This is theta right here. So if that is theta, that tells me that this side opposite theta, that's your opposite, okay? And the opposite is the numerator for tan, which is 4. So the opposite is 4. Actually, since we're going down, it's going to be, it has to be negative 4, okay? So this is a negative axis right here, negative x. All right, and then the adjacent, this is the adjacent. The adjacent is going to be negative 3, since this is a negative x-axis, right? All right, so in order to find sine and cosine, we need the hypotenuse, right? Because of this h and this h right here. We don't know what the hypotenuse is, but can we find it? Absolutely, we can use the Pythagorean Theorem to find it, okay, because this is a right triangle. All right, so these are the two legs. These are like A and B, and this is C, and we're looking for C. So I'm going to use the trig version of the Pythagorean Theorem. A squared plus O squared equals H squared. Okay, this is the same thing as A squared plus B squared equals C squared. Same thing. These are the legs, and this is the hypotenuse. Okay, so let's go ahead and find out what H is. A is so A is negative 3, so we have negative 3 squared. O is negative 4 squared equals H squared. Okay, so let's go ahead and square them. We're going to have 9 plus 16 equals H squared. H squared equals 25. Take the square root of both sides. H is going to be 5. Okay, so H is 5. So the hypotenuse in this case is 5. All right, so we have enough information to find sine and cosine, right? So let's see. With this information, I'm going to erase, well, let me do this on the side. With this information, we have to extend our partition a little bit so that it fits. It's going to encroach on my other space, but that's fine. I have that right there. So with this information, I know that sine theta is opposite of a hypotenuse, right? So sine theta is opposite of a hypotenuse from so is negative 4 over 5. And tan, I'm sorry, cosine theta is adjacent of a hypotenuse from chi and SOHCAHTOA. Adjacent is negative 3 and hypotenuse is 5. All right. So I'm going to use these two pieces of information to finish the problem off. All right, so let's go ahead and start with part A of the whole process. This is circular, so I can keep track of it. So first thing we need is sine theta over 2. We know that cosine is negative 3 over 5, so that's what I'm going to put in here. So we'll have sine theta over 2 equals plus or minus the square root of 1 minus negative 3 over 5 over 2 equals plus or minus the square root of 1 over 1 plus 3 over 5 over 2. Okay, we times this by 5 top and bottom. We'll have plus or minus the square root of 5 over 5 is 3 over 5 over 2. Okay, so now we have plus or minus the square root of 8 over 5 over, how about we express the denominator as a fraction also, so we have a match, okay? Now I'm going to multiply the numerator by the reciprocal of the denominator, so that's going to become plus or minus 8 over 5 times the reciprocal of the denominator, 1 over 2. Okay, so 2 goes here 1, 2 goes here 4 times. So we're going to have plus or minus the square root of 4 over the square root of 5. All right, 4 is a perfect square. If we root it, we're going to have 2, so plus or minus 2 over root 5. So we're going to rationalize the denominator. So root 5, since we can't have a square root in the denominator, and that yields plus or minus 2 root 5 over 5. Okay? Now, is sine 2 theta, is sine theta over 2, is it positive or negative? That's a question. Well, let's see. This graph right here is for theta. How about theta over 2? Well, we know that theta is between 180 and 270, right? So let's write that down here. 180 is less than theta. Theta is less than 270. To find theta over 2, all the quadrants for theta over 2, all we do is divide everything by 2. Okay, so divide this by 2, divide this by 2, and divide that by 2. So we're going to have 90 is less than theta. Since the lower bound is 90, then we know that theta, this is 135, right? We know that this is definitely going to be less than 180 degrees. Okay? Because this is 135, but I know that 135 is less than 180, so we know that this has to be in quadrant 2. All right? So looking at this, we draw a coordinate system. And then we have to figure out what quadrant we're at. 0, 90, 180. We're in quadrant number 2. Okay? So what does that mean? We know all students take calculus. Remember, we're looking at theta over 2 here, okay? I'm sorry, put theta over 2 here. Anyway, so S means sine and cosecant are positive. So since we're dealing with sine here, we have a match. Hence, this result is positive. So this answer is going to be 2 root 5 over 5. Positive 2 root 5 over 5 will be our answer for sine theta over 2. Okay? All right, let's go ahead and look for cosine theta over 2. Cosine theta over 2, we're going to use the formula plus or minus the square root of 1 plus cosine theta over 2. Okay? So we're going to have plus or minus the square root of 1 minus, I'm sorry, plus cosine theta is negative 3 over 5. Let's put it in here, negative 3 over 5 over 2. Okay, simplifying it further, we're going to have plus or minus the square root of, we can write it as 1 over 1 minus 3 over 5 over 2, because when you multiply minus and a plus, you have a minus, okay? So you have plus or minus the square root of 5 over 5 minus 3 over 5 over 2, which equals plus or minus the square root of 8 over 5, I'm sorry, 2 over 5, because when you multiply the top, you have 2. 2 over 5 over, how about write the denominator as a fraction 2? 2 over 1, okay? So that becomes plus or minus the square root of, we'll multiply the numerator, 2 over 5, by the reciprocal of the denominator, which is 1 over 2. Multiply across, we have plus or minus the square root of 2. We can just divide these out. Divide 2 goes here, 1, 2 goes here, 1. So it becomes 1 over 5. All right? We're going to divvy up the radical to the numerator and the denominator. So that becomes plus or minus 1 over root 5. And if we rationalize the denominator, root 5, we're going to have plus or minus root 1 of plus or minus root 5 over 5. What quadrant are we in? Same quadrant as here. We're still in this same problem between 90 and 180. So S basically tells us that only sine and cosecant are positive. So since cosine is neither sine or cosecant, we know that cosine theta over 2 is going to be negative because we don't have a match. It's negative root 5 over 5. All right, so there you have it. All right, so that's cosine theta over 2. Now let's go ahead and look for the last one, which is tan theta over 2. Okay, so for tan theta over 2, I have three choices to use. For this one, I'm going to use sine theta over 2 divided by cosine theta over 2. Okay, actually I have four choices to use, but this is the easiest one. All right, I'm just going to divide the two answers like I got before. So I have 2 root 5 over 5, which is sine, divided by cosine, which is negative root 5 over 5. Okay, I'm going to drop, change, flip, multiply the first by the reciprocal of the second, times negative 5 over root 5. All right. Okay, so what do we have here? We're going to notice that the radicals divide out, and also the 5's divide out to 1. When we multiply everything across, we're going to have negative 2. All right, so there goes your final answer for tan theta over 2. All right, so let's go ahead and organize our answers in a nice little list so it's easy to be read. So sine theta over 2 is 2 root 5 over 5. Cosine theta over 2 is negative root 5 over 5. And tan theta over 2 is negative 2. Okay? So there you have it. Now let's go ahead and take a look at the last question, question number 4. So for question 4, let's see. For this one, we're going to find the exact value of sine 75 degrees using the half angle identity. Using the half angle identity. Okay. And then verify your answer using the sum and difference identity. Okay, so we're going to use two methods to find the same, to find the value of this trig function sine 75, and then we're going to see if they agree. Okay, if they do, then we know we're correct. If they don't, then we know that we're horribly wrong. Okay, so what we're going to be doing, since our answers look different, we're going to be using a calculator to find a decimal approximation of this value right here. Okay, of our results. Sorry. So let's go ahead and do it. So we have the half angle. So part A is a half angle. Half angle. Okay, so we want to use a half angle to find sine 75 degrees. You automatically know that the angle here is half of a common angle. So we have alpha over 2 equals 75. So what is a common angle whose half is 75? We just simply double both sides to find out what the angle is. So we double both sides. So we have the fact that alpha equals 150 degrees. Okay. All right. So there goes the value of alpha. So now we're going to use the half angle identity for sine. We know that sine alpha over 2 equals plus or minus the square root of 1 minus cosine alpha over 2. Okay. All right, so let's go ahead and plug it in. Plug in the value of alpha, which is 150. So we're going to write this as sine 75 degrees equals sine 150 over 2, which equals plus or minus the square root of 1 minus cosine alpha, which is 150, okay? Over 2. Now, why don't let's resolve what the sine is so we don't keep writing plus or minus a million times. So, alpha over 2 is 75 degrees. So, where is 75 degrees if we draw our coordinate system? Where is 75 degrees? 75 degrees is between 0 and 90, right? So this is 0 and this is 90. 75 degrees is right here. So what do we know about quadrant 1? Well, we know that all students take calculus. So A basically means that all 6 trig functions are positive, so sine 75 has to be positive also. All right? So let's find out what 150 is. What is cosine 150? Well, let's consider a unit circle. If we look at a unit circle, 150 degrees is a point with coordinates negative root 3 over 2 for the x and 1/2 for the y. Okay, so this is the x and this is the y. Now, what do each coordinate mean? Well, we know that the x coordinate is your cosine and your y coordinate is your sine. Okay, so this basically tells me that cosine 150 equals negative root 3 over 2. Alright, so we're going to plug that in here. So this becomes plus or minus. Actually, we already know it's plus, so let's forget about writing plus or minus. So this becomes the square root of 1 minus negative root 3 over 2 over 2. Okay? So write this as a fraction. We're going to have the square root of 1 over 1 plus root 3 over 2 over 2. Okay, so we're gonna keep on going. This is gonna become the square root of 2 over 2 plus root 3 over 2 over 2. Okay, so it becomes combining the numerator 2 plus root 3 over 2 over 2 over 1. Square root of this entire business right here. Okay, so since we have a fraction on top and bottom, we can multiply the numerator by the reciprocal of the denominator. So we're going to have the square root of 2 plus root 3 over 2 times, you reciprocate the bottom, 1 over 2. Okay, if we multiply across, we're going to have the square root of 2 plus root 3 over 2 times 2, which is 4. Okay, we'll take the radical of the numerator and the denominator, so we have root 2 plus root 3, and then the square root of 4 is just 2. Okay, so this is the value of sine 75. All right. Okay, so we'll also have to find an approximate value for this. Okay, what is this approximately? So let's go ahead and find what the approximate value for this is. All right, so let's plug this into a calculator. So in the numerator, we'll have the square root of 2 plus the square root of 3. Close that, divided by 2. Okay, let's make sure our mode is in degrees first so we get the right answer. Okay, degree mode. Enter. So answer is 0.9659. All right, so let's put that down. So approximate answer is 0.9659. Now let's see if our second answer agrees with it. Okay, now we're going to use method 2. So this is method 1. So method 2 is the sum and difference identity. Sum and difference. All right, hopefully we get the same answer. So for this one, we're going to see if we can express the angle 75 degrees as the sum of two common angles, okay? Sum or difference. Let's use sum here. How about we express this as sine 30 plus 45, okay? So in this case, you notice we have alpha plus beta here, right? We have alpha, we have a sum, alpha plus beta. So we're going to be using the identity sine alpha plus beta. Notice the first one is alpha and the second is beta, equals sine alpha cosine beta plus cosine alpha sine beta. Okay? All right. Now we have alpha equals 30 degrees. Now, and beta equals what? 45. Okay, so I'm going to apply this formula to this problem. So we're going to have, this is going to become sine 30 plus 45 is equal to sine 30 cosine 45 plus cosine 30 sine 45. All right, and now to find what sine and cosine are, let's use your coordinates. So 30 degrees, if you look on a unit circle, is root 3 over 2, comma 1/2 for 30 degrees. And then for 45 degrees, the x and y coordinates are the same, root 2 over 2, root 2 over 2. So we have a little chart right here, trig chart right here. So we know that the x coordinate is cosine. So this is cosine. And we know that the y coordinate is sine. Okay? So this chart should tell me what sine, this is x. This grid should tell me what sine 30 and 45 are and cosine 30 and 45. Okay? All right, so referencing this chart, sine 30 is the y coordinate of 30, which is 1/2. Cosine 45 is the x coordinate of 45, which is root 2 over 2. Plus, cosine 30 is the x coordinate here, which is root 3 over 2. Times sine 45 is the y coordinate here, which is root 2 over 2. Okay? So let's multiply them out. So we're going to have root 2 over 4 plus root 6 over 4. All right? Expressing them as a combined fraction, it's basically root 2 plus root 6 divided by 4. You see how this looks different from the other answer? But the question is, are they the same? Let's find the approximate value of that. Hopefully we get the same result. Okay? So be careful how you enter this in the calculator. Watch this. You have parentheses first to separate to group the numerator together, since we have multiple terms in the numerator. So parentheses, the square root of 2 plus the square root of 6. Close the square root of 6, close the numerator, divided by 4. Answer 9659. Exactly. We have a perfect match. So this is approximately 0.9659. So we have to write a closing remark. Closing remark is that since the two results match, our answers are correct. Okay? Our answers are correct. All right, so there we have it. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here. And you can click like if you liked this video clip. And please post a comment. Tell me what you think. More clips can be found at theserve.com. Thanks again and have a wonderful day.